What's up, guys? So today I want to talk about horsepower, because everybody likes horsepower, but we forget that horsepower is not just about cars. Horsepower is just part of physics. So the equation for power in physics is work divided by time equals power. So to understand that, you first have to understand what work means. Work is force production times distance, or force times distance, strength times distance, however you want to look at it. The way I'm going to demonstrate it in this video is with a deadlift, because the deadlift is the easiest thing to calculate it with in the gym. The deadlift moves directly against the force of gravity straight up. So however much the bar weighs, that's how much force is required to lift it, and however far you lift it, that's how much distance it went. So if I look at my deadlift, the range of motion is 21 inches, and for this example, I used 275. The reason I used 275 is because that's the easiest number to calculate horsepower with, unless you're strong enough to deadlift 550, but I'm not strong enough to deadlift 550. So I used 275, and I found out that my range of motion is 21 inches. So that means if I take 275 and multiply it by 21 inches, I did 5,775 inch-pounds of work. In order to convert that to foot-pounds, I have to divide by 12, and then I get to 481.25 foot-pounds of work is being done when I deadlift 275 all the ways through my range of motion to the top. Once I do that, I need to figure out how long it takes. The best way to figure out how long it takes is with a stick like this. With this stick, I've got lines every inch, so I can put the camera up in front of my deadlift and videotape it. Then I could slow it down. I slowed it down so it's 5 times as slow, so then I could count. My camera will only count tenths of a second. If I had a better camera and I could get to hundredths of a second, I'd have a more accurate measurement. But I can only use tenths of a second, so I figure out, at 5 times slower speed, how long it takes, and then I divide that by 5 to get back to normal speed. And at normal speed, it takes me 0.7 seconds to lift the thing all the ways through 21-inch range of motion. So I have 481.25 foot-pounds of work being done in 0.7 seconds. So I do 481.25 divided by 0.7 equals whatever that equals. I'll put it in the video. I take that number and I divide it by 550, and I come up with 1.25 horsepower. The reason I divide by 550 is because 1 horsepower is 550 foot-pounds of work accomplished in a time of 1 second. That's the conversion factor to get from your work over time to horsepower, and then you have a single unit that you can measure in. So my average horsepower over the entire deadlift is 1.25, 1.25 horsepower. So while I already had the video and I already had all the marks on the stick, I figured I might as well figure out what my horsepower is at the lockout and what my horsepower is off the floor. So once I figured out my average was 1.25, I was pretty happy. My goal was just to break 1, so I did pretty good. Then I went from the floor and I figured out how long it takes me to move it for the first foot. And if I can just take that first foot, it makes my math a little bit easier, because I don't have to figure out inch-pounds and convert that to foot-pounds. I can start right with foot-pounds. So 275 pounds, 1 foot is 275 foot-pounds of work. Then all I need to do is figure out how long it takes me. So off the floor, the first foot takes me 1/2 of 1 second, which is exactly what is required for 1 horsepower. So off the floor, I have exactly 1 horsepower within the margin of error of my measuring devices. So I've got 1 horsepower off the floor, 1.25 horsepower average. Then I wanted to know what's my peak horsepower, which is going to be at the lockout, because I pull sumo. Everyone knows you're stronger at the end when you pull sumo. I didn't know that until recently. I used to think I was stronger at the beginning because I was doing it wrong. But I've been working on that with the coach, so I've been getting better. So my lockout is now actually the most powerful, which is what's supposed to happen. My lockout I simply measured the last 12 inches of my range of motion and figured out the time it takes to complete that. So the lockout takes me 0.28 seconds. So it's almost a quarter second. If I could get it down to a quarter second, I could get 2 horsepower, but I'm not that fast yet. So at my lockout, I take my 275 foot-pounds of work and I divide it by 0.28, and then I convert and I get to horsepower, where I have 1.78 horsepower at the lockout. So that's my peak horsepower. That's like when you see somebody's car and they still got the stickers on it, and it tells you the manufacturer's peak horsepower and peak torque. The peak is just the most it ever produced, so that's what they tell you. They don't tell you the average horsepower when you're driving the car. They tell you the most. So when anyone asks me how much power I could produce, I'm going to tell them 1.78. I'm not going to tell them 1 1/4, because it sounds a lot cooler if you give them the peak horsepower. Anyways, I just thought that was an interesting kind of physics experiment. And, you know, physics is important to everything. Physics is the basis for all of reality. So, fun thing to try out. I'm not sure how useful it is for training, but, you know, maybe somebody that's knows more about training will find this little math formula and make some use out of it. As far as I'm concerned, it's just fun to know how much horsepower you have. Hope you guys like that, and see you next time.